Hello, game theorists. So let's talk about that extra credit game we had on midterm 1. So as a quick reminder, here's how the rules work. So you pick a number from 0 to 10 and you're playing against another student in this class. If you both pick the same number, then that's your payoff. If you pick different numbers, then the one who picks the lower number gets that number plus 2. The one who picked the higher number is getting the lower number minus 2. Let's divide the payoff by 4 to figure out how many extra credit points you get. So, as an example, let's say player A picks 0 and player B is going for 1. The lower number is 0, so A is getting 0 plus 2 and B is getting 0 minus 2. So you can see that it's possible to lose extra credit points in this game, so you're not compelled to play. And some of you guys did opt out of playing, which is fine. But many of you participated, so let's see what happened among those who played the game. So I made a graph of the results. Let me go and pull that up. This one. Oh, first I should talk about the theory of the game. So if both players only care about extra credit points, then the Nash equilibrium is both players picking 0. Here's how I can see that. So you can see it's desirable to be the one with the lower number. Like in our example here, player A is getting positive 2 because they picked the lower number, and B is getting negative 2. So you always want to be the lower number. So you're going to try to undercut your opponent, and they want to try to undercut you, so they keep bidding it down until both players are picking 0. You can quickly verify that neither player can gain from switching from 0. So we're both playing 0, then our payoff is 0, right? But if I try to deviate, if I pick, let's say, 7, and you're still playing 0, then I'm going to make myself worse off. If I pick 7, you pick 0, the lower number is 0, so I'd be getting 0 minus 2, which is negative 2. So deviating gives me negative 2, sticking with 0, 0 gives me 0, so I don't want to deviate. By symmetry, the opponent also does not want to switch, so they'll both stick to playing 0. So that's what happens in theory. Now, in practice, though, well, first I should say in theory, let me just clarify that a bit. That's in theory if you care only about extra credit points. If you also care about cooperation, if you like cooperating with people, then that could be part of your payoff. If your payoff is both extra credit points and cooperation, it could be rational to pick something other than 0, as long as you value cooperation highly enough. So the cooperative outcome here, ideally, would be you guys both pick 10. So you pick the same number, in this case 10, that's your payoff, so you're both getting 10. So to convert that payoff to extra credit points, we divide by 4. It says in our directions over here. So you both pick 10, you get 10, and 10 divided by 4 is 2.5. So that's what cooperation would look like. So some of you guys were cooperators who played 10 and hoped to get a partner who also played 10. Some of the other guys were playing more for the playing less cooperative, playing for the 0-0 equilibrium, and a couple of you fell in between. So here's a distribution of what you guys did. So the most popular choice was from the cooperators playing 10. We had 10 of those players. And the other extreme was have the Nash players, I call them, who are playing 0. And it turned out we had a fairly substantial number of players who were picking 1 instead. So 1's not the Nash equilibrium if there's Nash equilibrium, assuming no value from cooperation, that is. But it did get a following among the players. So one thing I like to do is look at who did better in practice. The Nash players going for 0 or the cooperators who played 10. So the cooperators do well when they meet another cooperator. If they both play 10, they're both getting 2.5 extra credit points. The problem though is that if you're a cooperator, you get burned if you're paired with a Nash player. So Nash players can exploit the cooperators, but when a Nash player meets another Nash player and they're both playing 0, they get nothing. So I calculated. Um, so here's the variables telling you if it's a Nash player or a cooperator or neither. And I found out how many points each Nash player got, how many points each cooperator got. And our average Nash player scored 2 points of extra credit, but our average cooperator scored 4.8. So there was enough cooperation out there to make that choice to cooperate work out well in practice. So I've had my students play this game on midterm 1 for a couple of semesters now, so we have some historical data to compare to. So this class was fairly cooperative, I think in line with the results I've seen earlier. Let me show you what happened in the other semesters. Let's see. I think this one's fall 2020. So back then, the most popular choice was 0, going for the no cooperation outcome. There were still a fair number of people who picked 10, going for cooperation, but they were outnumbered by the Nash players, picking 0. And overall, the Nash players scored higher on average than the cooperators. So at the time, I was thinking that because fall 2020 was an online course, that's more impersonal. You don't know your classmates quite so well. You don't chat with them before class starts. So I thought that the impersonal nature of the class might have weakened social ties and made people less cooperative. That's a story I tried to sell, but this class is also online, and you guys are still fairly cooperative. And the online fall 2020 class, they look kind of uncooperative here. They did get more cooperative later on the semester. We can also compare with another class. This class was taught in 1 BC, BC meaning before COVID, so or as most people refer to it as fall 2019. This was face-to-face, and we still had a fairly large number of cooperators there, and not quite so many people playing uncooperatively, going for 0. So in that face-to-face class, the cooperators ended up outscoring the Nash players. But we got a similar result this semester, which is online. So perhaps the online versus face-to-face actually might not matter a whole lot for cooperation. But we still have some more games with cooperation and being a possible factor, so I guess we'll get some more data on whether online education affects cooperation. So that's all I have to say for now for our midterm 1 game. So stay tuned for more in-class games. We'll hear about cooperation or the lack thereof.